With this year's harsh winter and near-record snows, talk and concern has grown about the potential for serious spring flooding. To set the record straight on the existing potential, the Weather First team of meteorologists has been researching the topic. And in this in-depth CBS 2 special report, we'll bring you the facts and potential straight from the experts.
We try to use history to guide us in what may happen in the future, but this year we cannot find any analog years. There's really no conditions that match up to historic years.
It's been a brutal winter that doesn't want to end across the upper Midwest. Record snow and well below normal temperatures continue into March, with a parade of winter storms still on the horizon. The snow keeps piling up, especially to the north, where many area rivers begin, leading to an elevated flood risk this spring. The latest outlook has a 100% chance of major flooding along the Mississippi River and a 65% chance along the Cedar. That's more than 7 times the typical seasonal risk. It's early March and I am in Austin, Minnesota, and off to the left of me is the frozen Cedar River. This is the headwaters of the Cedar. This is where it all begins, and from here the river will travel 340 miles to the Mississippi. It'll travel through places like Charles City and Cedar Falls and Cedar Rapids. And up this way you can see the snow is massive. We're talking at least 3 feet on the ground here with a moisture content of 5 or 6 inches. And eventually this is all going to melt. And what happens here will determine what happens on our rivers in eastern Iowa when all this water goes downstream. Those that have lived through major floods in the past can't help but ask what this spring may bring, especially with memories of 2008 still fresh in the minds of many. But really, in terms of comparison, this year is closer to another big flood year in the past, one that had its largest impacts on the Mississippi River.
1965 is probably the closest year that we can come up with, because that was a very heavy snowpack year, just like what we had. But there was different conditions going into the winter time frame than what we have now.
There are 4 key ingredients that go into the flood outlook: soil moisture, the frost depth, river stream flows, and the water equivalent of the snow, or how much moisture the snowpack contains.
Iowa had its 3rd wettest meteorological fall on record, immediately followed by the 3rd wettest winter. Soil moisture levels across Iowa and the upper Midwest are at near record highs as a result. So it doesn't just have to do with all the snow that's sitting on the ground. It's important what's happening below. And what's happening below is the ground is frozen and the soil is saturated. So when the spring rains come and the snow starts to melt away, if the ground hasn't thawed and dried out, all that water has to go somewhere, and it's going to run off into areas, streams and rivers. Right now, those streams and rivers are flowing normally. Some of them still have ice on top of them, but when the ice melts and the runoff starts to happen, that will change. Now, these are important factors we have to consider with the flooding, but the growing concern is coming from the immense snowpack that's sitting just up to our north.
It has been an amazing year for snow around the upper Midwest. In some areas, record snows have fallen. Here in Austin, so much of it, they don't even have any place to put it. And the big question becomes, what happens to all of this moisture that's in the snow when it decides to melt?
The flood risk is high because of the extensive snow cover and record snows that fell in northern Iowa, southern Minnesota, and north central Wisconsin. In this general region, there's about 1 to 4 feet of snow on the ground, and you can imagine there's a substantial amount of water in that snowpack. In fact, north central Iowa, there's about 2 to 4 inches of water in that snow. So when it melts, it'll likely run off into the Iowa and Cedar River. In southern Minnesota, as much as 3 to 6 inches of water is in that snowpack. That is also where the headwaters of the Cedar River originate. So again, as that snow begins to melt, some of that runoff could likely get into the Cedar River with some rises downstream. And then finally, north central Wisconsin, there's as much as 4 to 9 inches of liquid water in that snowpack. So rivers and tributaries likely will be on the rise, which will all flow into the Mississippi River, with nearly a 100% chance of major flooding occurring from Dubuque down to Keokuk. And it's not out of the question some places could get near record crest.
The wild card that we'll deal with this spring is precipitation. It's impossible to know exactly how strong spring storms will be and where the heaviest rain and snow will fall. There was great concern of a snowmelt flood in 2008. However, A nearly perfect thaw, nice and gradual in nature, kept early spring flooding to a minimum. Flooding did not result until the end of May and early June, when record rains and soggy soils led to the historic event. Also, we're not done with winter yet. Any additional snowfall could just add to the current snowpack, increasing the amount of moisture that will come down the rivers in the spring. Forecasters at the National Weather Service are continually working with the North Central River Forecast Center, providing the latest snow forecasts.
We have a certain number of counties, and so that's true of our office, of the Des Moines office, La Crosse, Davenport, and so many others. And the River Center is coordinating and collaborating with all of us.
And so these are kind of our official long-term outlooks.
The River Forecast Center puts out 2 long-term outlooks in the spring, one in late February and another just released in early March. These outlooks involve a significant amount of computer processing power, as well as forecaster intuition and intervention.
We can essentially put in more snow in the snowpack if we see, if there's surveys that say that there's more snow than what our model is producing, so we can add the snow. If people are noticing that we're getting snow melt, we can go and make that snow melt change as well. If there's an increase in precipitation or temperatures, or we can also adjust what's called the hydrograph, or the timing of that snow melt as well. So we can go in and make our individual modifications based on our experience.
The river flood forecast models are really only as good as all the data that goes into them. And to make sure you get a complete picture of all this snow that's on the ground, you really do need a combination of low-tech measurement and high-tech observation.
So we found a spot that's representative of the snow cover in the yard, and we're going to take the 8-inch bucket, put it through, and get a snow core.
We've talked about snow water equivalent, but measuring it is not as easy as just using a ruler to measure the snow depth.
Now we have to clear all around it.
One way to collect this information is to grab a snow core sample.
Once you start to get about a foot or more of the snowpack, then we need to use the bigger gauge, because this obviously won't catch all of it.
Make sure I don't overflow if I have that much.
As we melt it down, we'll pour it into the other tube with the funnel, and then take a measurement with a ruler.
So we stick that down. It's very apparent where it comes out to on the ruler. 1 point.
It's a 16-inch snowpack with 2 inches of water is less of a concern for flooding than a 16-inch snowpack with 3 inches of water.
But there's a lot of gaps. Not everyone lives somewhere that they can take a manual snow measurement.
Enter the Twin Otter aircraft. When it comes to spring river forecasting, a lot of people, of course, think of river gauges, the amount of rain that has fallen, and the snow depth being measured at the ground. But aircraft like this capture another very important piece of data, and that's the water equivalent of all that snow that's on the ground.
This machine here has a series of crystals inside it.
This National Oceanic and Atmospheric Administration aircraft is equipped with a special machine that measures the radiation levels naturally emitted from the soil, called gamma radiation. Twice a year, this aircraft flies over a line, or a specific path designated at risk of flooding by the National Weather Service.
So we hit those lines in the fall, and then again the lines in the winter as well. Comparing the two SWE numbers, the soil moisture, and then the snow water equivalent numbers, gets an idea of how much water is in the snow itself.
Readings are taken over parts of the Midwest and areas of southern Canada. The mission, which takes a few weeks to conduct, requires 2 pilots, and the data can be collected just by using a tablet at the front.
The pilot, who's seen in the right-hand seat, will be backing up the pilot flying, kind of keeping them an eye on terrain and everything else like that, but they're also primarily operating the equipment. They're operating this tablet right here, which is our interface with the equipment in the back, to kind of make sure that the health of the crystals and the flight lines are being collected, doing their quality check and everything else like that.
So every day when we land, we get the data from this box to our computer. We send that over to the National Weather Service, and they incorporate that almost immediately into their flood models.
Because that fills in the gaps that we can put within our models and have a higher confidence level in our forecasting.
Now that the forecasts have been made, it's time for people to begin planning for potential flooding. For many emergency managers, the planning's been going on for months.
We knew it was kind of coming last year with as wet as the fall was. And then with the snow melt or the snowpack that's up north.
We're constantly monitoring that, kind of in a forward-thinking approach, and making sure that we're prepared to assist our communities in whatever kind of hazard might come their way.
Local emergency managers do not wait for these flood outlooks before stocking up on supplies. For example, Lynn County has 50,000 sandbags, about 400 super bags, as well as pumps and generators ready to go.
It doesn't make good financial sense or fiscal sense or even common sense to store tens of thousands or hundreds of thousands of sandbags when you may or may not use them. So we do the best we can. We pick a good amount that we need to get us started, and we have good partners we can order more and get more on hand as the threat presents and as it grows.
Part of the reason agencies have material on site is the fact flood seasons as of late do not follow historical timelines. Last year's October flood was a good example of this.
And it used to be that we get the spring snow melt and have to close the flood wall, and now it seems like we're doing it more often, you know, in late summer and even the fall last year with all the extreme rain events that we've been seeing lately. If we do get record crests, and it's going to be stressing the flood wall, and you know, we don't want to give a false sense of security to everybody, you know, that the river, you know, Mother Nature can do an awful lot, but you know, the city does an excellent job of maintaining it.
Based on all the facts and evidence we've been able to gather and measure, all of eastern Iowa's rivers and streams have an enhanced risk of spring flooding. Two rivers which stand out as prime candidates are the Cedar and Mississippi, which are directly influenced by the record snowfall that exists to our north. What we don't know, and what will ultimately determine the outcome and its severity, is how fast the spring thaw comes and how much precipitation occurs along with it. All we can do now is wait, watch, and hope for the best. In the meantime, rest assured the Weather First team will be watching and in constant contact with the experts to keep you safe and informed. For meteorologists Nick Stewart, Rebecca Kopelman, and Brandon Marshall, I'm meteorologist Terry Swales. Thanks for watching.